Okay. Assalamualaikum. Today we want to present JFET and MOSFET. So let me introduce our group mate. First we have Abdul Hazim bin Abdul Hakim, and we have Asyraf bin Adam Musa, and myself Muhammad Azraei bin Shamsol Anuar. First we go on FET. What is FET? FET is field effect transistor. FET is a key electronic component using within many areas of electronics industry. The FET is used in numerous circuits made from discrete electronic components in field ranging from RF technology to power management and electronic switching to general amplification. The concept of the field effect transistor is based around the concept that charge on a nearby object can attract charge within a semiconductor channel. It essentially operates using an electric field effect. The fact it consists of semiconductor channel with electrodes at either end referring to as the drain and the sources. The gate is control is situated relative close to the channel so that electric charge can impact the channel. So this is type of field effect resistor. So the field effect transistor divide by two, which is junction FET and metal oxide semiconductor FET. First, we go on junction FET. Junction FET has depletion mode, which it's also divide by two, which is N channel and P channel. Next, we go on metal oxide semiconductor FET. This also divide by two, which is depletion mode and enhanced mode. So we go on the depression mode first. It also divide by two, which is N channel, P channel. Uh, some same goes on enhancer mode, divide by two, which is N channel and P channel. So I will pass this to my group mate Abdul Hazim.
I will explain about the difference between JFET and MOSFET. The JFET only operate in depletion mode, but the MOSFET operate in both depletion and enhancement mode. Then the JFET has less input than MOSFET. The gate current on JFET is higher compared to the MOSFET. The signal handling capacity on JFET also lower than than MOSFET. Next. Next I will explain about basic structure of JFET. Basic structure of JFET at N-channel JFET. On either side of an N-type semiconductor silicon wafer, a PN junction is formed, resulting in a structure with two PN junctions sandwiching a N-type channel. The gate are the two P region, with the drain on one end and the source on the other of the N-type silicon. Next, the P channel. The P channel for a JFET has for a JFET with P channel N and P should be switched. Um, or, or the P channel, the N channel sandwiching the P channel. Next, the operation for JFET and channel. When the VGS equal to 0, VGS means gate source voltage. The drain current is generated by a majority carrier drifting between the drain and the source. When the VGS equal to 0, the PN junction is reverse bias, resulting in a depletion layer. When the channel between the drain and the source narrows, the ID decrease. The channel will decrease even more if VGS continue to diminish, and the ID will plummet until it approach 0 ampere. The JFET P channel uh, next the JFET P channel, the JFET P channel behaves similarly to the N channel, but the polarities and current are inverted. I will pass to my another group member, Haziq Asyraf.
So this is the basic structure of MOSFET. A MOSFET is a four-terminal device having source, gate, drain and body, and also connection. The source terminal is linked to the body of MOSFET, creating a three-terminal device similar to a field effect transistor. MOSFET are usually referred to as transistors and are employed in both analog and digital circuitry. Depletion MOSFET and also known as DMOSFET. The DMOSFET has two modes of operation, depletion and enhancement. To operate in depletion mode, the gate is made more negative, essentially narrowing or depleting the electron channel. N-channel. N-channel is a connection between a drain and a source. N-type semiconductors are used for the drain and source, whereas P-type semiconductors are used for the body. The gate terminal of this type of depletion MOSFET receive a positive voltage. P-channel. The voltage polarity and current direction are inverted. Therefore, it functions similarly to N-channel. Next. Enhancement MOSFET, or also known as E-MOSFET. If there is no voltage at the gate terminal, the gadget does not conduct. The device conductivity improves when the maximum voltage is placed across the gate terminal. N-channel. In N-channel enhancement mode, no current flow through the transistor until the voltage at the gate and terminal source reach the minimum voltage cut-in value. There is no apparent current flow even when the voltage at the drain and terminal source is applied. P-channel. The voltage polarity and current direction are inverted, therefore it functions similarly to N-channel. This is the example of calculation that we make. So the maximum drain current IDSS is equal to 313 milliampere. Pinch off voltage VP equal to negative 9 voltage. This is the calculate of the drain current for. If VGS equal to 0 voltage, maximum current flow through source to drain. Hence the amount of ID is the same as IDSS. So next. Thank you. Hopefully this explanation may help you to fully understand about JFET and MOSFET. That's all from our group.